Welcome to section 3.4, techniques in graphing. So there are going to be many techniques that I explained today in these notes. I would like you to pick your favorite way, run with it, and you can graph each problem whichever method you prefer. So I'll give you a bunch of options. Know that you don't need to know all of them. Just pick which one works best for you. So first thing to look at, order of operations for graphing. There is kind of an order of operation you need to follow if you prefer this way. First thing you want to do is look if there's a negative sign outside of your function. If there is, that means you're going to flip over the x-axis, which means your y values change. Think of symmetry. Okay, I like to make that very clear. If in the parenthesis or in the absolute value or in the square root, if there is something being added, you actually go the opposite direction. If something's being subtracted within the function, go the opposite direction to the right. Can you kind of think of point slope form? You always do the opposite of what's in parentheses. Same thing here. Another kind of reflection as we read left to right would be if there's a negative sign inside the function on your x value. Well, that means you're going to flip over the y-axis. In other words, your x values change. Think back to symmetry. The last option you have here is if there's a value being added to the end of the function. Plus c means you go up, minus c means you go down. C is any number, my dears. It could be 5, 7, 32, 105, any number. You just have to notice where it is within the function. So I have two very good examples to start, and then we'll actually graph today. First thing is, this is the general function of y equals absolute value of x. Notice I am adding 2 at the very end. So that means I follow it. I go up 2 and now I graph that absolute value. I have a minus 2. That tells me I'm going to go down 2 and graph the same function. So this is my c value at the very end that I go the same direction. Versus comparing that absolute value to this parabola. This is my general function, y equals x squared. This time if I add 5 inside the parenthesis, I go the opposite direction. Here I'm subtracting 5 within the squared term, so I go the opposite direction. I go now positive 5. So it's very important to know where these c values are, and we will practice that now. We're going to use transformations of the graph y equals absolute value of x to graph the equation y equals negative absolute value x plus 2 plus 3. A lot of things happen here. First thing, I want to know the general shape. Well, because there's an absolute value, I know it's going to be a v. We remember that from like day 2 or day 3, talked about general shapes. That's super important to know what it should look like as a reference. The positive 2 in the absolute value tells me to go the opposite direction. The plus 3 at the end is telling me to go up 3. Make that look better. We have to note though there's this negative sign. Since the negative sign is outside of the function, it's going to look like our first case over here, which means we're going to flip over the x-axis. We're going to be symmetric with that x-axis. So instead of it opening up like this, because of that negative sign, I'm going to put little dots. Because of that negative sign, I'm actually going to now open down. The way that I like to make sure I'm graphing correctly, when you do this XY table, it's going to help you. It's going to guide you that it's going to open down. So I'm going to put my vertex in the middle. Always a great idea. So it's -2 up 3. I know it's going to be a V shape. I now know it's going to go down, but let's plug in some points to see. Maybe I try -1. Well, I'm going to show you that step. If it's -1, I'm going back to the original equation. Instead of x, put -1. And we're going to solve for the y value. So this would equal negative. In the absolute value, I get +1. What comes out is positive, but since there's that negative, so my y value would be 2. If I input -1, I would get out 2. So -1 up 2. Oh, look it. Good. It's starting to go down. That should happen. Let's pick a couple other points. How about I pick -3? Let's do the same thing. Go to your original function. This time, instead of plugging in an x, you're going to put -3. Oops. When we simplify, -3 plus 2 is -1. Absolute value of -1 is positive. However, there's a negative sign out front, so I actually end up also getting y is 2. So -3 up 2. I would pick maybe 1 or 2 more points. I'm actually going to move this down a little, just to make sure we have a really solid graph. So maybe I pick -4 and 0. Pause the video very fast and find the y values. Hopefully you paused it. I got 1 and 1. So when I graph this, 0, 1, -4, 1, and there is my solid V shape. And just like that negative sign told me, it's going to open down. So even if I didn't catch that red negative sign, when you do the XY table, it just forces you to see it. Okay, now that's with a negative sign out in front. Let's look at a problem now where the negative sign is inside the function. This one's a little bit different. Again, many ways to do it. It's up to you. So what I'm going to do is actually set what's inside equal to 0, because I'm trying to find where x is 0. So when I subtract 2, I get -x equals -2. I'm getting the point x equals 2. When I plug in x equals 2, if I plug in, you get -2 plus 2. That's 0. Absolute value of 0 is 0. So I know something about the point 2, 0 is going to be on my graph. Think back. What should this graph look like? Well, it should be kind of a half parabola looking thing. So that's what I'm going for. I do have to keep in mind this negative sign. But the best thing I can do right now, a solid XY table. This point right here is 2, 0. It's not called a vertex anymore. It's called like the starting point. So you definitely want that on your graph to me it looks like it's going to open to the right. So why don't I try a value to the right? Why don't I try 3? Let me plug in 3 to the original. Ooh, I get absolute value of -1. We're not going to deal with any imaginaries here because we're actually trying to graph the point. So if I get an absolute value of a negative number, it's not possible. That means my graph is not going to go to the right. I'm going to get negative under the square root. Okay, well that kind of helps me. Now I realize maybe because of this negative sign, I might go in that direction. Right? Still the same curve, but just flipped a different direction. How about if I plug in, I don't know, like -2? If I plug in -2, you get -2 plus 2. So I get 2 plus 2 is 4 under the absolute value. So I get y to be 2. -2 up 2. I know it's going to be a nice curvy shape, so voila, that could be my graph. Okay. So it does take time. The XY table will be your best friend because it will help you in your graph. Couple more. Example 3, there's no negative sign outside or inside on that x value. So this one's actually super nice. There's no symmetry, no reflective needed. So I can just treat this like a normal fun problem. This -2 tells me go to the right, you do the opposite. This -1, you keep -1. This is your vertex. So if I graph it, 2, 1. Let's think of the general shape. Since it is a squared term, I'm going to have a nice little parabola action. Again, go back to day 2, I believe, and look through those graphs. And then we whip out our XY table. Let's put our vertex in the middle. Let's pick a value to the right, a value to the left, and we're going to plug into the original function to find my y value. So if I plug in x is 1, so I'm in the original problem, instead of x, you put a 1. This becomes -1 squared. Remember, -1 squared is +1. Times 3 is 3, minus 1 is 2. So the y value should be 2. If I plug in 3, pause the video, tell me what the y value is. Hopefully you paused it and you tried and you get 2 as well. Make sure you graph a nice curvy shape, a nice U shape, because it's a parabola. You guys are doing great. Okay, we have another one of these square roots. So I know it's going to have half parabola action. Ugh, I see a negative sign. I don't get nervous. I just have to be aware of it. Negative on the outside means you're going to reflect over the x. So your y values will change. Looking at it without the negative sign, I would start at the point -2, -1. Right, that's my starting point because of this positive and negative. So -2, -1. I know my y values are going to change. I'm going to flip over the x. So I'm actually thinking my graph might look something like this. Again, let's verify. Let's use our XY table. The point -2, -1. I'm guessing it's going to look like that, but let's verify. What if I plug in like -3. You get -3 plus 2 under a square root. That means you'll get a negative under a square root. Again, not possible. So nothing over here is going to work in my graph. Let's try a point to the right. How about you try -1? If I plug in -1 plus 2 is 1, absolute value of 1 is 1. -1 minus 1, wow, that's a lot of ones. -2. Interesting. You have to be smart about your points. Would I want to plug in 0? No, right? Because you would go to here and you would get 0 plus 2 under square root. So you have to do the square root of 2. I don't even know what that is. So I wouldn't pick 0, right? Be smart about the points you pick. Good point probably would be 2. Because 2 plus 2 is 4, and I know the square root of 4 is 2 times -1 minus 1, -3. So be smart about your points. Know the shape, and then you can move on. Here is some very good visuals for my visual learners, okay? There's some reflecting, there's some translating. The blue is the original function. Then the pink is that reflection or translation. So please look at these. They are helpful for my visual learners, and it explains to you what's happening in the little sentence down here. Okay. Very helpful for my visual peeps. Now the last problem. I'm going to get you started and I want to see what we can do. So thinking back to when we talked about the types of graphs we have, we talked about this kind of shape. I'm heading back to those notes. It is our fourth function we talked about, where there is a fraction with an x in the denominator. It's kind of very interesting. Okay, you will notice the shape, I'm going to draw my x-axis, was like this. So you can go back to those notes and verify. This is y equals 1 over x. So we have a little bit of translating to do. This +2 right here, just think of it as if it's like in the function. It's telling me to go to the left. This +2 is telling me to go up. Now the interesting part about this is it's actually not a point. When you have something that looks like this, you're going to deal with those asymptotes. So look what I'm going to do. I'm going to erase this. X equals -2 is an asymptote. And then y equals 2 is an asymptote. Okay, think of like these dashed lines right here. The graph's going to get very, very close, but it's not going to cross. So based on that +2 on the bottom, I know my graph cannot cross -2. I think the bottom can't be 0, right? That would make the bottom 0. The +2 in my y tells me that it's never going to equal y is 2. Now I do need to get an idea, like where are these points? So let's pick a point to the left, maybe -3, right? I love my XY tables. If I plug in -3, notice that's right over here. I'm going to see where my point is. If I plug in -3, I get +1. That is enough for me to hug those asymptotes and call it a day. That's enough right there. What if I plug in -1? Again, I'm just trying to figure out where is the graph. Is it going to be above or below? If I plug in -1, I get 3. Now that I have that, hug my asymptotes, and voila. Please make sure you take this video slow. If you need to go back and watch a couple more examples that I do, go do that. If you're ready for class tomorrow, I'll see you then, and we'll talk about all these reflections. Good luck, my dears.